welcome to another A-Level Computer Science video with me, Mr. Goff, for MrGoff.com. This video will provide an example of using child classes in a program. This video carries on with the model we created in the Using Classes video a couple of videos back in this playlist. If you haven't completed that yet, you should first go back and complete that. Our updated model for our animals class involves child classes for cat and dog. We're now going to implement these. So you can see in these examples here that our dog class is passed animal, which is its parent class, as a parameter. We then have its constructor, where we pass name, breed, age, and we preset type as dog, and we also pass the new attribute muzzle that is only applicable to dogs. We then make an explicit call to the constructor of the parent class, and we pass it the attributes required there, name, type, breed, and age, and it takes care of assigning these to self.name, self.type, self.breed, and self.age. We then assign self.muzzle separately ourselves. We then make getters and setters for self.muzzle, because all of the other attributes inherit the getters and setters from the animal class. We then also create our new string method in the dog class that also prints out whether the muzzle is required, that will override the method in the parent class. With our cat class, we once again pass animal so that we know that that is the parent class. In the constructor, we pass name, breed, age. We preset type as cat, and we also pass microchipped. We then call the parent constructor and pass and set name, type, breed, and age. We then handle microchipped separately. Then we create the getters and setters that are applicable to that particular attribute microchipped that we've just created. Next, we need to change our add an animal subroutine to add a cat, dog, or animal object to our animals array as is needed. So now, after we've got the type of them and the name, the breed, and the age, then we check, and if it's dog, we ask them about the muzzle. This next line might confuse some people. Muzzle equals Y. What we're saying is, if muzzle is equal to Y, then that will return true, and so muzzle will be equal to true. If muzzle is not set as Y, then it will return false, and muzzle will be set as false. We then append a dog object into our array. If the type turns out to be cat, we request the information on whether it's microchipped, and we use the same method to set microchipped as either true or false. We then append a cat object. If the type is neither dog or cat, we're just going to use our standard animal object, and we will create and append a new animal type. In order to prove this worked, I added a line to print the animals array each time the menu is called. You can see that our array contains a dog object, a cat object, and an animal object. You can also see that we've used the viewAnimals method, and it's had no problem printing out the details of each of our objects. That's because they all have a string method. The dog used its own personal string method because it overrides the one in the animal class. Both of the other objects used the string method from the animal class. Now it's time for you to try it for yourself by expanding on the program you made to create car objects. Create child classes of your cars class for convertibles and coupes. Each car should have attributes for the type of car that it is, as in a convertible or a coupe, or some other type, and the number of doors, and for coupes, that will always be 2 doors. Convertibles should have an extra attribute for roof type. This will either be hard or soft. Amend your add car subroutine so you either add a coupe, convertible, or other car type. Pause this video now while you try the task, and then come back and unpause it when you're ready for me to go through the solution. As well as the child classes below that we're going to go through, I also updated the car class so that all cars include the car type and number of seats. The convertible class gets past the car class because that's the parent class. We automatically set the type to convertible, and we also pass in the extra attribute of roof. We call the super constructor, and we pass most of the attributes there, dealing with roof separately afterwards. We then make a getter for roof, but we're not going to change the roof type of a car, so we don't need to make a setter for it. For the coupe, we pass car because that's the parent class. We automatically set coupe, and that's it. We just call the constructor of the parent class and pass all of our attributes. To change the add car method, I don't ask anymore for seats if the type is a coupe. Only if it's not a coupe do we need to know the number of seats, because all coupes have 2 seats. We also then check if the type is coupe and append a coupe, passing 2 as the number of seats. If the type is convertible, then we also ask them what roof type it is, and then we append a convertible object. If the type is neither coupe nor convertible, we use the standard car object to append a new car object to our array. In the example output below, you can see that each of our different car types has been stored in our array, but as all have a string method inherited from car, they can all be listed by our listCars method. And you can see that our system is still working, even though it now uses child classes. That brings us to the end of this video, giving an example of using child classes. Join me in the next video when I'll be having a look at aggregation and composition in object-oriented programming. Use the resources at mrgoff.com to help you revise computer science, and until next time, it's bye for now.